Today we have an interesting problem, and one that is unfortunately fairly common, and that is a sagging ridge beam. So not only is the beam sagging, but also the rafters are sagging coming down, and what that has done is that's actually pushed out the walls on both sides. It's a vaulted ceiling, partially vaulted. It's got collar ties, but they did not engineer the ceiling, and we're going to get into that in a second. I'm going to take you in. Before we go in, you can look up and you can see these vertical bricks here. They're actually leaning out. Now, I'm not talking about the design from them being kicked out like that, but the brick is actually leaning. It's kind of hard to see on the camera, but they are popped out. Okay, inside of here, we've got over a 4-foot span, about 1.5 inches off level. So, the anatomy of the structure is they've got two 2x12s that are just nailed together, and that is spanning about a 30-foot distance with support over that wall and this exterior wall. Then they have 2x8 collar ties that are spanning about 14 feet, and they are within that 1/3 of the top of the roof like they should be, but they only doubled them up twice across this distance. They doubled them up there and also right there. And that is where the ridge beam is being supported again by some cripples up there. But that's it. Over this long expanse, that's all they did. And that's led to some problems. Our plan to fix this is that we're going to, or that we already have, attached these 2x12s, both to the top plate and also to the wall studs here, with some 4.5-inch lags. This is what they look like. They've got a flat head, it's a T30, and that's what we're joining the 2x12 to the top plate and to the wall. So we had to get up there into the top plate, because if we just grabbed onto the studs and tried to pull, we would just be pulling the studs out from under the top plates, and then the whole roof would collapse and we'd all die. Well, probably not, but still, it would not be good. So what we've done is we've got U-bolts about every 16 inches going across. So the U-bolts are just in the 2x12. They've got a plate behind them and 2 nuts, and that is what is holding the U-bolts into the wall. And that's on both sides. The numbers are just to help align both the sides. And we're going to be hooking up our ratchet straps to there. Got our ratchet straps here. These are 27 feet long, and we're going to be cinching the walls back together. But we're not just going to be pulling, we're also going to be pushing on the ridge beam up there. So we have a few 12-ton and 20-ton jacks, and we're going to build some posts and jack up the ridge beam while we are pulling in the walls. Now thankfully the bricks outside, the bricks are, it's just the top bricks that have pushed out because of the design. Those vertical bricks have kind of saved that whole brick wall, because if they'd been laid horizontally like the rest of the bricks out there, the whole wall would be pushed over. But it created a nice break so that this wall has been pushing against those top bricks, and only the top bricks are really pushed out of level. Something else that I forgot to mention is that we have 2x6s cut into the 2x4s, and what that is all about. So we're doing some balloon framing here. This is called a let-in ledger, and basically you notch your studs and then you fit a ledger into the studs. That makes it so that all of the shear pressure is on the stud and not on nails or screws. What we're going to be doing is putting some I-joists sitting on top of our lead-in ledger. So there's been a laser line struck across, and so that's all perfectly straight, or about as perfect as you can get across there. And then those 2x6s are screwed and glued with polyurethane adhesive into the 2x4s. I'm going to go over the layout of the room and how I decided on the direction of the beam and the layout of the floor joists and how to fix the roof in the process. So this is the dimension of the room. It's 38.5 feet by 30 feet. About 12 feet in from this wall is a wall that I was going to build across it, which was going to serve to divide the garage space from the foyer and the mudroom. So there's another wall that's right here. Anyways, my original thought was, well, all I have to do is just put the joists running this way, and I'll just do it all the way across the room, and this will be my load-bearing support, and they'll, be bearing at 17.5 feet and roughly 12 feet on this side. So that's great. And I won't have to buy any expensive beams, and I'll just be going simply off of this wall that I build. But then I realized that I couldn't do that, and that was because the way the rafters are running. The rafters are running parallel with the length of the room, or the longest point of the room. So this is 38.5 feet across here, and I realized if I was going to be jacking up with my knee wall like this, putting pressure down directly on top of my joists, if my joists are all running this way, I would only be putting pressure down on one joist, and that one joist would not be able to support the load of the roof bearing down on it. In order to bring the pressure evenly across everything, I needed to have the joists running this way, parallel with the rafters. So that brought in this design, which is what we ended up doing. The rafters are running parallel with all the joists, and that means when the knee wall is put up, it will be each knee wall cripple that's going up there will be sitting directly on top of the joist. And so when I gave all of these measurements to Boise Cascade, they took all of this into account. So they put it into their software program, and they said, okay, bearing for the beam is at 17.5 feet, and then you're going to have I-joists that are going to be covering a 19-foot span from either direction, and then you're going to have load coming down from the roof onto the I-joists. And so they computed all of that, and they said that I needed a triple ply. So this is a triple ply 16-inch LVL. So 3 LVLs, and they're 16-inch, and that they needed to have 5-inch special truss lock lags every 12 inches all the way across the beam, 3 rows of them. And so they said with that design, and then using some BCI 6000s, 11 and 7/8, because that's the only spacing that we had available to us. So if we use BCI joists, 6000, 11 7/8 with a 2 3/8 flange, and I had them 12 inches on center, that I could span this and bring load down off of the roof, and I would have a very solid floor. Their computerized engineered spec sheet, and it gives it a very good deflection, which I believe it's over a 500, which 360 is like minimum, but I typically like to be over 480. And this floor I think might even be close to the 550, 560. Anyways, it's a very solid floor, feels great.
12 inches on center, not fun necessarily to work with after the fact for drilling holes and doing any kind of plumbing. So make sure that your plumbing and electrical are thought through. I mean, electrical is not a big deal to go through, but it's hard to fit a standard drill in between. There's just not a lot of space. But it's especially important because the eye joists have a limit for where you can drill through them, and you've got to make sure that you've got slope for your drains. And so that is something to think about, is where all of this is. Like, we've got a kitchen right above this area, and then a bathroom with fixtures over here, and so all of that needs to be thought through before you go with any of this engineering, because you don't want to do all of this and then find that your plumbing, electrical, well, mainly your plumbing or your HVAC isn't going to work with your setup. Like this 16-inch 3-ply LVL beam can only have a 2-inch hole maximum drilled into it. So 2 inches is basically the outside diameter of a 1.5-inch PVC. So no toilet can be on this side of this beam. Talk with your plumber before going with any kind of flooring design. Think through it.
So we've got a 3-ply 16-inch LVL beam, and it is 26 feet long, or a little under 26 feet long. It's got median support here at about 18 feet, and we've got a rather large footer, as you can see, for it right here and over on that wall. About 9 inches by 5.5 inches is the bearing surface. So we've got the ratchet straps and the U-bolts, and we're going to be tossing the ratchet straps over the beam to begin pulling tension. At this point, it kind of looks like a jungle gym, but the ratchet straps are up and they've been tightened to where they're holding, not really pulling on the wall though. So a couple of things that I've learned as I've gone along. First thing, these straps, while they are assisting in pulling in the wall, they really aren't doing a whole lot. They are holding it when I release tension, and they're a good idea, but they don't have the strength to be able to pull the walls in. My posts that I'm using to jack up are two 2x4s with a 2x4 on the back, so that it has dimensional stability both in the X and Y axis. Just makes it so they don't twist or bow as they're going up. Now, it would probably be a good idea to double sandwich your posts, as I did with that one. And if you're going from a greater height than, say, 10 or 12 feet like I am, then you'll really probably want to use 2x6s in the same kind of configuration, because it's a lot of pressure. I've also got them clamped to either the collar ties or a supporting member up there that also helps them at that point not to bow or twist out. Everything is nailed to a collar tie or something else that also has to go up, so that if a jack suddenly shoots out or whatever, the jack might fall, the blocks on top of it might fall, but the post itself will not fall. You do not want a post coming down on your head. This beam is wanting to twist one way or the other. I've got some blocks underneath that jack right there, and that helps, but you need to be aware that you've got to get this pretty well balanced as far as its load pushing down on it, or this beam over this long span will twist. It doesn't seem to be pushing down, but it is twisting. I put little tiny collar ties up there in the very top with a 5-inch flat lock screw going through them to help keep the ridge beam and the rafters from separating, because as I was pushing up on the ridge beam originally, the rafters started to separate from it, and I realized that I'm putting a ton of pressure on the ridge beam, but the only thing that's holding the rafters onto the ridge beam is their weight and the nails, And so as I was pushing up, they started to separate. So I took some 2x8s, cut them to the approximate pitch of the roof, and then just put in one flat lock lag through the collar ties to hold them in place, to act as just basically holding the rafters together underneath the ridge beam. And that just keeps it from separating from the ridge beam. I wanted to go through what we've done up to this point. We are jacking up the ridge with these temporary posts, which are just a few 2x4s that are nailed together, and then they have a 2x6 on the back that is nailed to them to keep them from twisting. Pushing up against a double 2x4 and 2x6 kind of beam that is going across additional collar ties that I set right below the ridge beam to try to distribute weight, moving it all up as a unit. A flat lock lag right next to that nail, so it's got kind of a hinge point, but it is holding onto that rafter so that as I push up, it's not going to just be breaking off the rafter from the ridge beam. As we were going along, we had our 2x12 that was up attached to the top plates, and we were pulling the walls in with these ratchet straps. Here's the last one. And so going across the room, they were all strapped together, and that did help, but obviously the ratchet strap's primary purpose was to assist the wall coming in and to hold tension. It was not meant to do all of the work itself. Typically you use the same material, so in this case an I-joist, as the blocking member between I-joists on this end so that they cannot roll. Instead what I'm doing is I'm doing squash blocks pushing up on the top plate, and those are acting as basically what's going to hold the I-joist in place. I might come back and put some blocking in between all of this, but for right now that's how I've got it, and then I'm going to insulate between all of that space, and then I might put some blocking, but technically you're supposed to have your blocking in that stud space. Over on this side, I did 1-inch blocks on either side of the web. They're 9 1/4, so one side or the other is not touching the flange, so they're not wedged in there this way. And then I'm using the specifier nail hole to stick in a 1.5-inch nail into there, and then I am toe nailing the flange into the LVL, and that is keeping this just nice and firm. It's not going to move, it won't twist or rotate or pull out, which is my main concern until I get the knee walls built that will be bearing more of the weight of the rafters. So that is what I've done to remediate this problem, and the exterior roof is nice and flat across it. The rafters are still sagging in this point, but I will be tackling that next. Once we get the subfloor down and building the knee wall, I will individually be jacking up each rafter to get it straight across here. I had to get around some AC lines that were coming in, the Freon lines, and so I had to do a double 2x12 header there, and I will be hanging the I-joist off of that header. I reinforce both of the I-joists on either side with 2x10s, and so they are glued and screwed to the I-joist. That should be plenty secure. So how we got the rafters to all be level with each other, I'll show you. Putting a bar across, you can see this is a 6-foot level, and they're all touching across here. How we did that was we individually jacked each rafter up. Let me take you over to this side of the room. This is what it looked like before. These have not been done yet. You can see large gaps between the rafters, or even so much as, so all across here, all of these are uneven. And so the method of fixing them is using a board like this as a jack and staying above the joist, which is why we have everything 12-inch on center, is it all falls right above these, so you're putting pressure down on your joist underneath, and nailing or screwing a block into the ground and then hitting the top with a sledgehammer, and that will push the rafter up until you can align it with the side of the cripples. So you can see here, this is a level mark down to there, and how that mark is decided by what the original was, which is over here. So up against this wall, this is the end wall, so nothing fell here because it was well supported, and so this is the level mark, and so whatever this size of rafter is, that's what all of these, or not, sorry, not rafter, cripple, whatever size this cripple is here, should determine the rest of these. You can see this one right here is about 1.25 inches or 1.5 inches off. That one's the same, but then right here, this rafter was not so bad. This rafter is only like 1/2 inch off of its mark. But then immediately the rafter next to it, way off. So some of these rafters fell quite a bit more than others. But all of them need to return to their original position. So here's the process, spanning multiple joists. We've got 4 different jacks holding up each of the rafters, and we're just going one by one, and then we'll pull the last jack over to the next one, and then move the other one over to the next one, and keep on hopping. Sometimes they need to be toe nailed, sometimes they need a block behind, just a cleat in the ground to hold them in position. But now the difference is we have rafters that are much closer together and touching across multiple spans. And so that is what we're going for, with everything being all together. But some of these are difficult to get up into position. You just have to be patient and keep moving jacks around. It has been a couple of weeks since we worked on the jacking of the rafters to get them into position, but wanted to show you the doubling up we did of what were the collar ties. Now that this is the second floor, they're acting more as the ceiling joists. They were doubled up across here, and on top of them we have cripples going up from the top of them, pushing up on the ridge. So every single one of those collar ties or ceiling joists is now supporting the ridge all the way across. The most important thing is that we have fixed the sagging roof problem, and all of these rafters are in line with one another. You can see I've got some 5-inch lags, 2 of them, going through, tying all 3 of them together, and that is done on every single one of these, though it looks like my helper stuck them too close right there. That's what you don't want. You don't want them close together. They're not going to do as much good as if they're spread apart. I'll show you the outside so you can see how it looks from out there now. And there it is, the exterior of the house, and you can see nice straight ridge across there, and the roof rafters are all flat and straight, no more dip to be seen on the roof. Some of the shingles did shift, but that is easily repairable. Sometimes you can just let it sit in the sun and bake a little bit and the shingles might fix themselves, but otherwise go up, pop a couple of tabs loose, and then nail them back down in their new position. Here we are on the other side, and you can see it too is nice and flat. The ridge is all straightened, and yeah, it's just looking better. hopefully this has given you some ideas, maybe help you problem solve, and you can see what it takes to fix a structure like this.